Welcome back for your 7th ACT math video. So please set a timer for 8 minutes and work on those 6 questions while this video is paused. Once the timer runs out, you may restart this video. For number 31, the simplest form, basically what it's saying is you want to rationalize the denominator. You don't want radicals in the denominator. Now to rationalize something that looks like this, you need to multiply it by the conjugate of the bottom. The conjugate at the bottom is where you flip the sign of the radical. So that's your first line of attack. To get rid of the radical, use the conjugate. Flip that sign. And now we're going to take care of this. So on the bottom, what you're going to end up with is you're going to end up foiling this. Remember, whenever you're multiplying two binomials, you can use the FOIL method. So here, 36 plus 6 square roots of 3 minus 6 square roots of 3 minus square root of 9. So we're going to use the FOIL method on this. Well, notice the inside cancels right away. 6 square roots of 3 minus 6 square roots of 3. And now the cool thing is, you know what that is. You know that the square root of 9 is just the number 3. So the cool thing is that bottom just turns into 36 minus 3, which is going to be 33. And on top, you have that. Now notice I didn't multiply the top through because leaving it like this, I think is easier to see something. It's easier to see that the 3 and the 33 can reduce into 1 over 11. So when you properly reduce this, you're going to end up with 6 plus square roots of 3 over 11. That is going to be answer B. This one, which of the following is a root of the polynomial? So there's a few ways to solve quadratics. The way we've previously covered in videos is factoring. Now, if you look at your answer choices though, factoring is clearly not what's going on here. You don't want to factor this. Those are showing the quadratic formula. So let me remind you what the quadratic formula looks like. Oh, I'm sorry, started writing it wrong. So it would be a very good idea to remember that formula, okay? It may come in handy. So with the 2 being the A, negative 6B, and C being 3, now it's a matter of just plugging it in. So negative B would be positive 6 plus or minus negative 6 squared minus 4 times A times C all over 2 times A. All right, now what I tell my students is clean up this mess first. Just plug that part into your calculator. And when you do, that'll actually boil down to just 12. Now, notice that's not one of your answer choices, because another skill that they want you to have is being able to simplify radicals. So remember, the square root of 12 splits up into 4 and 3. And because we know what the square root of 4 is, we can actually end up writing it as 2 square roots of 3. And now, because every one of these, all the coefficients are divisible by 2, that actually ends up being able to be reduced to 3 plus or minus square root of 3 over 2. So you will get answer choice B for that one. Number 33 is another quadratic formula problem. So this time your A is negative 16, your B is 134, and your C is 3. So let's plug that in. So negative 134 plus or minus the square root of 134 squared minus 4 times a times c all over 2 times a. So again, when you clear out that mess, you end up with 18,148 inside the radical of the negative 32. Now, this time notice they're not leaving it in exact form, okay? They're actually letting you use your calculator to simplify this. So what they want you to do is actually get the two answers as decimals. So take 134 plus the square root of 18,148, then divide it by negative 32, and you get negative 0.02. That's using the plus half. Using the minus half, negative 134 minus the square root of 18,148 divided by negative 32, that's going to give you a positive 8.4. Now, if you're thinking about it, you are looking at the seconds for the ball to hit the ground. Well, considering you can't have negative time, that's why they rule out that choice right away. You can't have negative time, so your answer is going to be that 8.4. What is the slope of any line that's perpendicular to the line 5x minus 2y equals 3? So here we're talking about slope. And in that conversation of slope, that means you have to be able to determine it from the original line. Now looking at this, I can't determine the slope at this point, right? It's not in a form that I can tell. You can only see slope in y equals mx plus b form. That is how you see the slope. It's going to be the term with the x. So we need to solve this for y so we can actually see the original slope. So I'm going to subtract the 5x from both sides. Negative 2y equals negative 5x plus 3. I'm going to divide everything by negative 2. So y equals negative divided by negative is positive. So I have positive 5 halves x minus 3 halves. So right now, this is the slope of my current line. I want the slope of the perpendicular line. Well, slope of the perpendicular line, if it were parallel, a parallel line would have the same slope. But remember, perpendicular is a little bit different. Perpendicular is what's called the opposite reciprocal slope. So you flip your fraction and you change its sign. If it's positive, you make it negative. If it was negative, you switch it to be positive. That is how you find a perpendicular slope. So any line compared to that one is going to have a slope of negative 5 or negative 2/5. But again, another very common one is parallel. So I just wanted to introduce you to the idea that if I ask you for parallel, that is going to have the same slope. Both of those are equally used on ACT tests. What is the vertex of the parabola with that equation? Now, the nice thing about this is when talking about the vertex, well, this is already in that vertex form. If you recall, it's chapter 2 in Algebra 2. We talk so much about transformations. And this is a set of transformations. So remember, this is transforming it left 4 and up 8. Okay, so it's shifting that vertex to the left 4 and up 8. Well, if I'm going to the left 4, the left is a negative direction, and up is a positive direction. So we end up with negative 4, 8. Again, even though they don't specify this, for a normal quadratic, if they ever ask you for the vertex of a regular quadratic in standard form, remember this is that formula for finding the vertex. So write this down too. for if your equation is in standard form, that's how you can find the vertex from that. And finally, x-intercept. So the x-intercept. So for the x-intercept, it means y is 0. All right? So I'm going to plug in a 0 for that equation for y. And now if you notice, the cool thing is, it just kind of drops out. Divide by 3, and you already have your answer, 10/3. Now again, this particular one is asking for x-intercept, but what if it was asking for y? For the y-intercept, the x would be the 0. So again, just to show you both the ways it could be asked on the ACT, they equally ask either one. So the y-intercept would be -2. So again, just to make sure you're familiar with both ones, because either one could be the one that appears on the ACT. So thank you for joining us, and stay tuned for the next one, your 8th video.